Well, welcome everybody. Thanks for joining. We'll give it a couple more minutes here to allow some others to join in, get into the session. So we do not have Tiffany with us today. She's on vacation actually, so wish her a safe time away and relaxing time, hopefully. But the good news is we do have a guest speaker that's going to come and talk to us about Fusion and Eagle and some of the capabilities and benefits around electronics. So just give another minute or so here and I'll go ahead and introduce our guest speaker and we'll get started.
Excellent. Hey, Matthew, will I be able to share my screen? I'm not sure exactly how to do that, or is that something you need to perform?
You are presenter, so you should be able to, in the GoToWebinar panel, you should be able to see a show screen button. It's like a big play button. And then you can choose which screen. Do you see that?
Oh, okay, yeah. Would you like to capture? Does it let me select which monitor I want to share? Let me see.
Yeah, there's a drop down and you can choose which monitor.
Okay. 1 second. Okay.
All right, looks like the attendees list is slowing down a little bit. So Edwin, are you almost ready to get started?
Yeah, almost ready. It had to restart because of for it to be able to share my screen. Now I don't see the share play button anymore. Again, can you make me presenter again? I guess.
Yep.
Okay. Now it's letting me screen
There we go.
on my screen.
Okay.
Yes,
perfect.
That's the screen I would like to share. Yep.
Yep. Okay. So we're gonna go ahead and get started here. So just for those of you that have just joined, this is our monthly virtual meetup for AutoCAD Electrical and really anything kind of AutoCAD Electrical plus Vault related. So my name is Matthew Durst. Been with Autodesk for a little over 5 years now. I am a principal implementation consultant and my primary focus is around data management solutions. So working with Autodesk Vault primarily. So today, Tiffany will not be with us. She is on vacation. So we wish her a safe time away and fun and relaxing time as well. So, but on the flip side, the good news is we do have a guest speaker. So the format will be around 30 minutes of presentation around Eagle and Fusion on electronics. And then the second half of the session, we'll go ahead and hold that for Q&A. So if you want to populate the list with your questions during the presentation, we will get to those questions at the second half of our presentation. So yeah, so Edwin is a part of our BSM team, so Business Service Management, and yeah, he's with us today, and he's going to go ahead and present some material around Fusion 360 and Eagle. So Edwin, go ahead and take it away.
Thank you for the introduction, Matthew. I greatly appreciate it. Hi, everybody. I hope you're doing well and you're staying safe. Well, I joined the Autodesk company by means of an acquisition that happened 4 years ago. I had been working for a company called CADsoft Computer, which was the original company that actually created Eagle software under CADsoft Computer. Been working with them since the early 90s. Initially, I started my career as an electrical engineer in the communication industry here in Florida. I am located in South Florida. Then we became part of Farnell, which is also called Newark Electronics here in the United States. Did work with them for a little while until they they purchased or acquired Eagle from them. Joined them in July 4 years ago. So it's been really good, because ever since the acquisition, Eagle has been able to grow to much of its capabilities. Now, today in our presentation, I'm going to be primarily using Fusion 360 electronics. And the reason why I'm going to be doing that is that we're not going to be really sustaining Eagle and Fusion 360 for the extended period of time. We're going to be primarily working with Fusion 360 electronics. Now, Eagle is still available, and it still works with Fusion 360, but the bulk of my presentation today is going to be around Fusion 360. Now, the majority of the capabilities I will be explaining in Fusion 360 electronics are available through Eagle, as well as it actually does have a collaboration workflow with Fusion 360. Well, first of all, the primary intent of electronics is it needs a platform that needs to be intelligent, it needs to be able to collaborate, and it needs to be unified. With these three combinations, the creation of any product is required. Therefore, the electromechanical challenges that we actually encounter today is effective collaboration, not having to do file conversions. File conversions is the #1 inhibitor of actually going to market as fast as possible. Every time there's any type of modification, a series of file conversions need to be created one more time. A functional 3D is because the 3D exported usually are canvas based, so it's a flat screen. Therefore, it only looks really nice, but you cannot do much with it afterwards. So therefore, what do we actually need for a product design? We need a design environment that meets both the electrical and the mechanical requirements of the product. We need to be confident that we're always working with the most recent of the electrical and the mechanical design changes. And number 3, and last and most, is quickly respond to changes by other members of the team in the design. So what does all this boil down to? What we need as engineers to solve this problem is a singular model that is collaborative, united, as well as intelligent. And that's where the future of electromechanical product design is actually Fusion 360. As you already know, Fusion 360 is a cloud-based CAD/CAM tool for collaborative product development that combines industrial engineering, mechanical engineering, machine tool programming, simulation, electronics, all this into one solution. Gone are the days of having to use multiple applications for the development of your next product. Learn one interface using all these tools. Therefore, I'm going to actually break this down primarily to our electronic design capabilities. That's what I'm here for primarily. I'm going to be working with the electronic side of things. Now remember that a lot of these features that I'm going to be explaining here are available through Eagle as well, as it actually handshakes and collaborates actually very nicely with Fusion 360. The electronics editor in Fusion 360 actually is a combination of multiple editors. It boils down to a schematic editor, which is the logical representation of a circuit board, of course, a circuit board editor, and a very elaborate and very well-created library editor. Remember, the building blocks of any electronic design are going to be surrounded around having components in the libraries that are needed for your design. Now, we're not going to always have the right ones that you need. Therefore, having a library editor is a must. And third but not least, we're going to be talking a lot about the 3D PCB editor as well. Now, and I'll talk a lot about that. Now, let's talk a little bit about the features of the schematic editor. #1 feature that I'd like you to learn about is that it actually has real-time annotation. Therefore, modifications that need to be done to the circuit board or actually to the schematic will happen in real time with the circuit board. If you might need to have change components, yes, because there might be a component that is actually more economical or more efficient. You may have to change connections to the component to be able for that component to work as efficient as possible. Being able to have a platform that actually updates the circuit board or the schematic in real time is a must. With Fusion 360, we actually do have those capabilities. Now, the connections on a circuit board, or the connections defined on the schematic, actually may have some characteristics that need some special requirements. Let's say, for example, there's going to be a line on a schematic that's going to have a heavy load. Therefore, that line needs to be thicker than our conventional lines for our digital connections. With net classes we're able to actually specify and give special characteristics to our connections in the schematic, which are going to be obeyed by the design rule checker on the circuit board, and that's referred to as net classes. Now, primary thing, as I said earlier, is being able to have a nice repository of components that's going to be used on your schematic and your next design. Now, we do actually have a very large one. We have a team of librarians in which have added hundreds within hundreds of components to our library repository. But not only that, we've given access to distributors and manufacturers the capability of actually using our management system. That way they could actually add components to our library repository, and that becomes immediately available to our users as well. But in addition to that, the authors of those libraries can make the updates. Now, usually, if you wanted to use the latest updates from a component, you would actually have to visit the manufacturer or the distributor's website and download that component. Well, not with Fusion 360, because the manufacturers actually push the changes into a repository. Therefore, the users actually have the option to update the part and just go ahead and download it, update the library, and continue using it without having to go through all of the websites or trying to find the right part, or actually maybe paying somebody to make the parts for them as well. Now, currently at the time, we have Adafruit, SparkFun, Worth Electronics, and PCB Layout are actually contributing some of the parts. Now, we're going to be having many more distributors and manufacturers add to our repository in the near future as well. Now, let's talk about our PCB editor. Remember I told you earlier, we have a real-time annotation between board and schematic. Therefore, if I make changes on the board layout, it actually reflects those changes on the schematic, and this is in real time. Now, I like to talk about the PCB editor primarily as a design optimization procedure. Why? Because we've actually taken a lot of the guesswork of where you're working on your design for you. In other words, first step, real-time design rule checking. As you see on my GIF file here, you'll notice that you get these hatch lines where there's violations. Commonly, in other applications, you actually have to place the components, then run the checker to see what errors you have. With Fusion 360, you actually get that identified immediately. Therefore, you know that you're in violation, not having to then run 2 commands to find out what your violation is. You actually are getting them in real time. The other feature that we have, which is actually very elaborate, is our routing capabilities. When it comes to routing, it's maybe the hardest part of PCB editing capabilities. Now, we've added a significant amount of routing capabilities to Fusion 360 to optimize this process, such as being able to route multiple lines, but not only able to route multiple lines simultaneously, we're able to route multiple lines and give them guidance. That way it could follow a predetermined path defined by the user as well. Well, maybe you've already have a board that was routed by somebody else, but you would like to optimize that routing. Well, guess what? We also have a smooth router. So if lines are already routed, you could actually smooth them out with our quick route smoother as well. Now, the third and final, and this was just recently implemented, is an environment change. Push and shove was a topic that is primarily only done for routing. With Fusion 360, we've actually added this as an environment variable. In other words, now with push and shove as an environment setting, I could actually add components to my design, and guess what? It will plow its way through the existing design and move any traces and points of transition points of the traces. It will actually push them out of the way. That way I could actually make space for this new component. Traditionally, users would actually have to delete any obstacles that are in the way. They would actually have to rip up. In other words, any work they've done would be a totally waste of time. Now they actually are able to erase these components. They don't have to erase these components, but they would have to erase these components, place the new part, and then do the routing again. Now with Fusion 360, now they're actually able to just place the part, things will get out of the way, and use the routing, push and routing capabilities of Fusion 360. They'll make their way there. I can't tell you how many clicks, with thousands of clicks are actually being saved with this new process that we have. Also, last but not least, creating your manufacturing data, which is called the CAM processor. And when it comes to PCB design, we work with something called Gerber files. It's a one-click process. You only click on the manufacturing tab, and that will actually create all the files that are required to actually have your circuit board produced. Now, let's talk a little bit more about our library editor. On our library editor, the process usually takes several steps. We have our schematic symbol, which is the schematic representation on the schematic. And then we have our footprint, which is our representation on the circuit board in 2D. And we have our 3D model, which is attached to the footprint. That way, when you actually move from a 2D to a 3D, you actually get the appropriate 3D model representation for it. Well, guess what? With Fusion 360, we've added an IPC compliant calculator, which is a commission that actually predetermines that many manufacturers follow when creating their components. Well, we've actually added their calculator into our system. We've created a calculator compliant with their system in which it will create in the single step. It will create the footprint, which is what you're going to see on the circuit board layout, and it'll actually create the 3D model at the same time. Therefore, being able to build a footprint, which is kind of a lengthy process because you got to calculate the right grid and the correct spacing. And you were very prone to error in this process. By using a calculator, you could select one of our templates, just transfer the data from the manufacturer's specification sheet, and it will actually build a footprint for you. Therefore, it lowers the amount of errors or lowers the capability of having errors. And what does this translate to? That you may have to actually have the boards made or prototype. When you get them back, it's possible that the component just doesn't fit. It was just too, the component that was actually used, the landings are used, might be too big or too small. Then you may have to create an interface in which it actually lets you use the component you use. That way it's not a waste of money, or you got to send out for another batch. So being able to create this process, not only it's a time saver, it's a money saver as well. Now, the last but not least, we have expanded the capabilities of our calculator to have hardware. In other words, if you're going to have standoffs, if you're going to have circuit boards stacked up on top of each other, we have a lot of hardware as that. If you're going to have standoffs that hold the circuit board to a chassis, to an enclosure, we've added that as to our calculator as well. So other than the IPC compliant parts, we've actually expanded the capabilities to other non-IPC compliant parts as well. Now, Unified. I want to use Unified because of the 3D capabilities that we've done. So from the circuit board, I'm able to produce a 2D, it's not a canvas, it's not a render, it's actually a 2D representation of my, I could create a 3D, functional 3D representation of my circuit board. It is the collection of 3D models that have material properties that can be used in other workspaces in Fusion 360. Evaluating the heat loads and thermal performance on overall designs and use the e-cooling functionality. Other than that, we could actually use it to create realistic renders of our circuit board, the manufacturing diagrams, as well as inserting the 3D into our design workspace. So as you could see, it actually expands all of the capabilities of your traditional circuit board design. And this is a true paradigm shift in this area because nobody actually offered this. Traditionally, you would actually have to have different applications, different design tools to be able to do all these studies. With Fusion 360, we're able to actually just perform this under one platform. Now, let's talk a little bit about electromechanical workflows. And that's where we're king. That's where really makes a difference when it comes to using Fusion 360 for your designs, as well as Eagle as well. Now, the workflows are very relevant depending on how the team is going to be working with a product. And we've identified 3 primary workflows. Either the circuit board is going to be governing the enclosure geometry. The most typical one is that the enclosure geometry strictly guides the geometry of the circuit board. In other words, you capture the circuit board, let's say, for example, like a drill or any type of tool. the mechanical engineer is the one driving the tool. Therefore, the circuit board needs to be able to adapt to it. So we could capture that geometry as well. We could capture that geometry and use that as on our circuit board. Now, there will be times that the product design will be flexible. In other words, depending on the constraints of the circuit board, the mechanical engineer could apply. But if there's something that he needs to do, he could actually make that modification in which the electronic engineer could actually collaborate. To be able to accomplish this type of workflow would require a lot of phone calls, a lot of emails, a lot of messages between the electronic as well as the mechanical engineer. With Fusion 360, they actually see the comments between both teams directly in the application. In addition to that, they could see the changes done on one and adapt those changes if they feel it's necessary. Now, let's talk about how did we solve the electromechanical workflows without the need of file conversions. First of all is, we already told you how do we create the 3D PCB based on the circuit board. That's the center. That is the glue that now is going to be able to give us a full electromechanical workflows. So I could actually capture the geometry and apply that on my 3D PCB, or from the circuit board, I could create it. So everything stems from the 3D PCB, as you see. I either go to the enclosure, I go to the circuit board, I go to e-cooling. So all of this is actually centered around the 3D PCB. It's the nucleus of the electromechanical workflows. Now, let's talk a little bit about these electromechanical workflows and their capabilities. First of all, I'm able to capture the geometry by using what we call 3D PCB Create. Now, this is a very flexible style of capturing that we have, because once I capture the sketch geometry from the faces on my enclosure, I could apply that to my 2D PCB. To my 3D PCB, then I could have that adopted by my circuit board. And now that will become my layout. Okay, that will become the layout for the circuit board engineer, for the electronic engineer, to lay out the circuit board in exactly those restraints. Now, with 3D PCB, there's no link between the enclosure captured and any modifications to the circuit board. In other words, there's no link between them. It kind of leaves it open. So if I want to make modifications to the enclosure, which I could do, I could recapture the sketch profiles that were used, but I will have to start a brand new 3D PCB. So every time you make changes to my enclosure, you actually have to do a brand new set of 3D PCB. And that's kind of the downside of using the system. It's flexible, but it only goes in one direction. It does not link. Now, how did we solve that? We actually solved that recently by adding something called 3D, let me go here. We call it PCB derive, which is the next option. With PCB derive, we're able to now capture the geometry of an enclosure, but it remains linked with the 3D PCB and the circuit board. Therefore, changes that are done to the enclosure geometry, which affect the circuit board, will actually, not sure what's going on here. Okay, it came back. Okay, so any type of changes that are actually done to the geometry of the enclosure will be actually captured and linked, and it will, how should I say this? It actually will affect the 3D PCB and go all the way over to the circuit board as well. So it will adapt to any modifications. Now, it restricts what the electronic engineer can do to the outlines. He will not, the electronic engineer in this capability, with this type of workflow, cannot influence the board outline. He's totally locked out. The only thing that he could actually do is actually move the parts within the circuit board, and the mechanical engineer can decide to adopt any changes that the electronic engineer could do. But any type of mechanical changes done to the design will actually have to be created on the design workspace only. Now, okay. that takes care of the slides. I'm just going to go ahead and launch Fusion really quick. That way I could show you some of the other capabilities that I wanted to show you on the mechanical engineering side as well. Is that okay, Matthew?
Yeah, absolutely. We do have just a couple, actually just kind of one question coming in, so we'll hold that till the end. But if there are other questions for Ed, please start putting those into the question pane if you could. But yeah, Ed, go ahead and you can start with your demo. That'd be great.
Okay, very well. Let me just go with, I just had to launch it again. Just give me one moment.
Yep, no problem. And just while we're waiting, in the chat window, I went ahead and sent some information as far as where you could view previous recordings as well as sign up and register for the next virtual meetup. So again, we try to do this once a month. Um, our, our normal speaker, Tiffany, again, is not here due to being on vacation. But yeah, we do have the benefit of inviting a guest speaker, which Ed is here for us, and it's great to get a different source of information than typically what we're used to. So the feedback has been good so far, Ed, as far as a great source of information, and some said that the capabilities of electrical are a little bit over their head, but it's good to be looking in the future, right?
Yeah, so
So.
you know, the idea of today I wanted to present was not so much the details of electronics, but the capabilities that it has, and maybe present the current challenges that engineers are actually running into, and how this Fusion 360 has been able to fix that for the production of any product. Okay, so let me. I'm sorry, it took me out of the data folder I wanted to use for today's presentation. So give me one moment. Let's go ahead and find it really quick.
And if there's anybody that also, if you want to unmute and you can ask your question live as well, if you don't want to put it into the question pane, we can do that as well. I believe there is a raise your hand function. So if you want to raise your hand, we can take you off mute and you can ask Ed any questions live.
Yeah, sure. You said there was a question right now. Any chance I could just maybe address it if it's while I find my data set? I
Yeah,
want
yeah, it's
to
more
move here.
so about I think access to it. So they wanted to know, is there a student version of Fusion 360 electronics?
Well, it's not so much Fusion 360 electronics. Yes, there is a student version of Fusion 360, period. Fusion 360 has the electronic capability. So it's not a separate module or anything like that, as you could see here. And I just want to try to load this really quick. And that way I could work with this data set. I used it for a demo yesterday and I'm having a little bit of a hard time finding it. So give me one moment.
Yeah, no problem. I can see if I can locate some more information. If you are a student, I believe all you need is the EDU email address and you can sign up and get access to a lot of Autodesk software,
Correct.
through your
Correct.
student. Yeah.
So I had this loaded a minute ago. So
Well, that's the curse of live demos, right?
yeah, I really was using it literally. I had it open this morning, getting ready for today's presentation. I had it open, and yes, when I went to go in, that's why I went in a little later than what I expected. Something kind of froze up here, and I lost it. So I will try to go ahead and use something else that I have. I may have a different data set. I'll try to use that instead. Well, first of all, I'm not sure if it's my data connection or what's going on, but I'm getting a lot of this today. Okay.
And just for anybody else that's interested, I put a link in the chat on where you can get started to get access to educational or educational access to Autodesk products like Fusion 360. So that's a good place to start. And Sophia, you are welcome.
Okay, yeah, that's not gonna work. So, okay. So first of all, let's go and show you how you access the electronics in Fusion 360. Okay. When you launch Fusion 360 for the first time, it looks like this. It takes you directly to the design workspace. You'll see the different workspaces available right here on the left-hand side. To access the electronic workspace, what you're gonna do is that you're gonna click on the File pull-down menu and select here where it says Electronic Designs. This is gonna bring you to what we call the electronic document. During my presentation today, I kept on always saying that we have annotation between the schematic and the circuit board. And this is controlled by what we call the electronic document. To begin your brand new schematic, you're gonna just click here where it says brand new schematic. This will bring you to the Schematic Editor. And this is where I actually wanna show you an interface paradigm that we have that we've really been able to adopt. This is the design workspace in Fusion 360. We have solid, surface, sheet metal, and as you see, the icons change, the toolbars change depending on which tab you have open. Well, in the electronics, we have exactly that. We've adopted the exact same interface. As you see, we have the primary tools that were necessary for schematic editing, and by changing your tab, we actually get the other ones that are required for your design as well. Now, I could start going and start adding components to my design. This is a schematic, so I'm only going to be getting some schematic symbols for these components. So I'll get some IC logic. Now, components already have 3D models, as you could see, and you'll actually preview the 3D model as well. So we have the schematic symbol representation, we have the footprint representation, which is going to show up on the circuit board, and we get the 3D model as well. Let's find something a bit more interesting than this. Okay.
And Ed, we have a few more questions when you're ready.
Go ahead.
Okay. The first question, can we perform live operation of electronic processes through Fusion 360 in AutoCAD?
No, as far as I know, we do not have that capability as at this moment, no. No.
Okay.
Is it something that they wish to implement? From what I've heard from Matt Berggren, it seems that they do want to be able to implement something like that, but I don't know where that is on the roadmap at this moment. No. So as far as I know, no, not yet.
Okay, very good. And then another question here, Fusion 360 is mainly for electromechanical question mark. So kind of just confirming, is that what Fusion 360 is mainly for? Electromechanical
No,
workflows?
no, not really. Fusion 360 electromechanical workflows, yes, came up in January when this was implemented. Fusion 360 is a tool by which it's primarily only for mechanical engineers, as well as for tooling purposes, as well as CAD CAM solutions as well, and simulation. But when I say simulation, I mean material simulation, not so much electronic simulation. Electronic simulation was actually implemented when electronic was added this January. So it's a lot more than just for electromechanical capabilities. It's a tool primarily used for, eventually it's going to have like mold flow, but it's a lot more than just for electromechanical. It's a lot more than that. I wish I would be
Okay.
able to tell you a lot more, but I'm only an electrical guy. But I know
Yeah,
it's a lot more than just that.
so on the electrical side, is there anything for electrical engineer that can correlate within Fusion 360
Well, when it comes to it's primarily for electronics, to be honest with you, primarily
Mm-hmm.
electronics.
Mm-hmm.
So is that's the difference we're doing here, electrical and electronics, right?
Yep.
Yeah, that line is a little blurry at times, but yes, this is primarily for electronics only at this moment.
Good.
only for
Good.
electronics. Okay.
I think that's a great way to answer that. Yep.
Yeah, when I've done some presentation with some other team members, I always have to point out the difference between the electrical teams and the electronic teams. Now, as you see, I just put a couple parts here because I know I'm a little over the time that I really wanted to work on this. I just put a couple parts in the schematic editor, and this is where the annotation beauty comes in Fusion 360. Once I switch to my circuit board, it will actually create the circuit board for me. It will come up with a default board outline with all the components showed up on the left-hand side, as you could see. I can now go ahead and start selecting these parts and add them to my circuit board. Let's go grab these components. I just grab a couple components, a voltage regulator and a USB. And now to switch to the 3D PCB, I could go here and just click here where it says View in 3D PCB. And now this 3D PCB is not a canvas, as I said earlier. It's actually truly extruded, constructed bodies. As you can see, it actually creates a timeline for the actual components. And each component, as you see here, each component is going to show up here with all the details that were actually built for that component in itself. Now, here comes some of the magic that we have and we offer here. Once I save my 3D PCB, and a lot of mechanical engineers actually like this workflow. Why? Because now the electronic engineer now can influence the circuit board design from a reality 3D perspective. Now let's go back to our circuit board. You'll see that the circuit board, I have my components here on the bottom left-hand corner. If the mechanical engineer actually prefers to lay out the circuit board from this perspective, no problem. He's actually able to select here where it says move, select the component, and actually bring it in and move the parts. But I have a couple options. If these components were actually have connections between them and they were routed, I could actually tell it, you know what, I want you to update the circuit board. And if there was any type of routing, any type of connection path between these components, I could select the option reroute. Go here and go ahead and click OK. And what's going to happen is that it's going to now go in between the circuit board and the 3D PCB, and it's going to update. You're going to notice that the landings are now going to go to the correct part. And if we go over to the circuit board, to the 2D layout, you'll notice that this the component is actually now at its new position. Let's go ahead and run a line between them. Let me just run a connection really quick over here in the schematic. I'll run a connection between my volts here and my volt bus here. Okay. Now the nice thing of using the environment within Fusion 360, it's since I made a change, it's letting me know that my 2D and my 3D are out of sync. I'm just going to go ahead and route this real quick. Get this routed. Well, let's go ahead and update and synchronize the 3D and the 2D PCB as well. Okay, as you see the trace happen here. Now, here's one more thing I wanted to show you. If I go ahead and I move this part, but this time I'm going to select update the PCB and update the routing, and I'm going to select this component that I wish to move. I'll just move it to the side over here, right there. Once I click OK, it's actually going to synchronize between the 2D and the 3D and actually update this trace. It's actually going to find a new path for this trace. As you see here, it optimizes path. But if I go and I check my 2D, I'll notice that it actually adopted that change as well right here. So this type of interface, or this type of workflow has never existed this tight between the circuit board layout and the between the electronic engineer as well as the mechanical engineer. So if we could actually push this into into the design workspace and create an enclosure around that. And that's a topic really for another day to be able to accomplish that. In essence, this is what I really wanted to show you today, Matt. So I don't know if anybody has any other questions that you would like to do. So this kind of ends our presentation for today.
No, I think that's great. I think it's a great introduction into what Fusion 360 is capable of on the electronics side, and then showing the workflow between all the different groups, I think is excellent that never existed before, and we have a solution for that. So again, thank you for the presentation. Thank you for the demo. I'm checking the question pane right now. It looks like we're all caught up as far as questions for today. So I'll just give it another minute or so if there's any other questions
I
while
was
we have
trying to
Ed
see,
here.
yeah, I was trying to see if I could find that enclosure that I wanted to demo today on today's demo. So give me, well, we see
I
if
just
any,
see something that said enclosure demonstration. Is that it?
yeah, let's take a look now. It said webinar August 2020. It was the name of it. Um, it was actually the name of it. And let me go to my tech marketing folder to see if it's there by any chance. Go to the smart box, smart meter. And then we'll go here to enclosure and enclosure sandbox. So, okay, so here. I just want to do one more to see if I'm able to accomplish it really quick, Matthew, in which being able, I keep on telling you about being able to capture the geometry of an enclosure to use it on my circuit board. And this is where I actually want to show it to you really quick, okay? Because this is the true electromechanical workflow. This is the whole idea behind this, was to be able to capture geometries, complex geometries, and use it on the PCB layout. That is the primary electromechanical workflow challenge that currently exists. Being able, the mechanical engineer, to be able to provide the complex geometry of an enclosure to electronic engineer, an accurate one. That way he knows where all the holes are going to be, where the standoffs are going to be. That's the actual main challenge that the electromechanical workflows actually are at. So I'm trying to load this. It's just for some reason today my system is working a little bit on the slow side. I made sure I closed many things I had in the background.
Yeah, and while we're waiting, another question had just come in. Fusion 360 output, can that interface with any other 3D tools? Like, can we import, export options from other 3D tools to Fusion 360? Is that possible?
As far as I know, yes, there's many tool. There is the option. Well, okay. So if we're going to talk about electronic design tools, okay, if we're talking only electronics, the only import capability that Fusion 360 has for electronics would be Eagle. That's it. In other words, there's other electronic design capability tools available that Fusion 360 is not able to import. So if we're talking electronics, no. Now, if we're talking mechanical, as far as I know, Fusion 360 is able to absorb almost any of them. So let's say like SolidWorks, and some other ones. I'm not a mechanical guy, so I'm sorry, I don't know the names of the other applications. But like SolidWorks, or it has a system called AutoCAD, and when it comes to mechanical designs, it's able to import almost anything. But when it comes to electronics, it's only compatible with Eagle.
Very good. Another question here, is this part of standard 360 or is it an add-on?
No, this is part of standard 360. No, you don't have to add anything or anything like that. This is standard with it.
Perfect, perfect.
Well, I'm having a little bit of a hard time. I know I'm way above the time, but I don't know why it's giving me such a difficult time today. Sorry about that.
No, this is actually perfect. I think demo / questions, I think is a good thing. This is typically how we run the webinars. Tiffany will kind of demo stuff live and people will just kind of ask questions, and seems to work out pretty
Okay.
good. So yeah, you're not over time until we get
Okay,
to the
very
top
well.
of the hour. So.
Okay. So I just wanted to show you. So this is, in essence, what the electromechanical workflow you want to reach. You want to be able to work on the circuit board design. On this one, I actually have 4 circuit boards. This is a smart meter. I don't know if the camera's still on, if you could see me, but this is what this is. It's just, No, the camera's not on. Okay. I thought it was on. I have one. I have one of these on my desk. Okay, so this actually has one circuit board on the bottom, a IoT solution board. This is just that way it has Internet of Things communication, like Bluetooth and Internet. And then we have 3 add-on boards with the different types of sensors that you're going to be using. And then it has another circuit board for the panel, as well as here. So this is what a true electromechanical challenge is. So to be able to accomplish this would really need many applications. So one dedicated for circuit board design and then export step, a different one for the mechanical aspects of it. And then if you wanted to do some e-cooling simulation, there would be a different application. And for rendering, if you want like a true render for your marketing team, then that would you would use a third-party tool like Keyshot to be able to do it. With Fusion 360, you're able to actually combine all the projects into one. At no point in time there was any type of file conversions, at no point in time. In addition to that, I'm actually able to assemble it to make sure that everything is actually gonna correlate and all of my geometries are gonna match the geometries of my enclosure and have no errors when I actually make this product true.
I think that's really cool. Yeah. Also the fact that you have a physical um, display to show as well. I know your camera wasn't on, but yeah, that's really cool. Really cool stuff. Um, yeah, a couple other points of feedback. We got some excited users. They actually let their 360 expire, so they're looking to renew their 360 to get back into this. So they were excited about the presentation. Um,
Excellent.
and then another question here, is there any intention to move AutoCAD Electrical into Fusion as well?
I don't know enough about that. You know, to be really honest with you, Matt, it would make total sense if they did have a version of it or in its totality into Fusion 360. It makes total sense, but I'm not aware of it. I'm not part of that team to know about that development. I don't know. We've had this question come up a couple times already from other team members and actually from users that are avid users of AutoCAD Electrical. So we've had that question come along a lot of times, and there's some capabilities when it comes to wire harnessing that AutoCAD Electrical have that we don't have, that we would truly be able to adapt to this and make it a reality from a lot of users when they have to be able to do some wire harnessing. Like in this version right here, I wish I had that capability because there's a lot of connectors. As you see here, these are external access connectors that I have here, this one here, and from here. This is actually supposed to connect to my display board, and I wish I would be able to easily demonstrate this wire harnessing right here, and I'm not able to because it does not really have that capability. So
Yeah,
it
so
would be
for
nice.
that specific capability, we have Inventor with AutoCAD Electrical and actually with Vault as well too. There's an electromechanical workflow where you can show the wire harnessing, just like you're talking about there. So I would like to see it in the future, right? We have that full package solution.
Hmm.
So I think, yeah, at some point we might get there, but yeah, probably seeing how the response is between the usage of Inventor with ACAD so far.
I also wanted to mention that if you were to visit the Fusion 360 YouTube page, there's a section, many other sections for the other capabilities of Fusion 360, but we actually have a playlist or subsection onto the Fusion 360 YouTube page, and I'm constantly adding content to there and in the form of tutorials. So they're 3-minute tutorials of how to be able to access the libraries, how to be able to capture enclosure geometry and adapt it to your circuit board, how to manage your libraries, and yes, a host of different topics. Right now, we only have 40, around 40 videos posted, but we're adding more on a weekly basis, and we're trying to do as many as 2 or 3 live streams every month in which our users could actually participate and post live questions to us as well. So make sure to sign up for one of those if you still are interested as well.
No, that's great. We have around 170,000 subscribers to Autodesk Fusion 360 YouTube channel. And I do see the playlist of electronics design, which you have about 38 videos on there.
Mhm.
So I can actually
Mhm.
share that. Um, Oh, there it's playing right there. I can actually share that with the user group here.
Now, I wanted to comment as well. Eagle circuit board layout, which is schematic board layout and router, all the same capabilities I demonstrated today. Eagle's been around for over 30 years, and Eagle actually was actually kind of a generation shift when the open hardware kind of movement came along. Eagle was actually in the center of all of this. Since we always had a free version of Eagle, we still have a free version of Eagle. Therefore, if you visit DigiKey, Mouser, a lot of times they offer their libraries in Eagle compatible format. If you visit websites make websites such as like Adafruit or SparkFun or Seed Studios, which provide you kits, electronic kits for you to be able to build your own projects. Well, guess what? The libraries and the design files are in Eagle format. Well, that format is 100% compatible with Fusion 360 as well. So you're able to just upload the Eagle design files and continue working with them in Fusion 360. So you have 30 years of data out there in the market, which you could actually just repurpose in Fusion 360.
That's great. That's really good stuff there. Okay, we are just under 10 minutes left. Looks like we're all caught up in the questions pane. Ed, anything else you can think of? Maybe some last words you can leave with the users?
Don't be shy in trying it out. If you were to visit pages like instructables.com, there are many electronic projects available on instructables.com, which is an extension of Autodesk. Find an electronic project of your interest, maybe something with some LEDs, maybe some Christmas decoration, or maybe just a stand that you want to put a trophy or something like that with some LEDs. Just go over to instructables.com. They provide you the videos and all the steps of being able to create that project, and just follow along that project and build your own. Start with something small, maybe with a handful of components, actually put it together. Having the boards made, they're approximately like $5 for a square inch, and they'll send you like 3 boards. So you could spend like under $50 to get 3 boards made, and then you could practice a little bit of your own soldering stations. You could get them for like $30 or less. So you could actually put together your own electronics as well. Of course, I know everybody knows about Arduino. Arduino's files were done in Eagle, so they're 100% compatible with Fusion. But if you actually want to put something 100% together yourself, I encourage you to visit instructables.com, find a project of your interest, and maybe put it together yourself and do some soldering and see it blink, see it light up, and then who knows, maybe next thing you know, you're doing something a lot more elaborate.
Oh, that's really great, Ed. And I actually just went to the website and I provided a link in the chat as well. So anybody that's interested, yeah, go ahead and feel free to visit the instructables.com website, as well as go to the YouTube Fusion 360 channel. Please subscribe to it and you'll get notified about any new videos around electronics design or anything else Fusion 360. So looks like the feedback was good today. So Ed, you're a big hit. And again, thank you for joining us. We appreciate it. And everyone have a wonderful day. Thank you.
It's been a pleasure. Hey, Matthew, and thank you for the opportunity, and all those that attended, thank you for taking the time and be here with us, and have a great day and stay safe.
Yep. Thank you. All right. Bye-bye, everyone.
You bet. For now.